Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we are the second group and we're going to present for subject industrial organic chemistry. And our team members is consists of Husna, Izafatini, Faris, me, Maisara, Shohada and also Afiq. And we're going to explain for the chapter 2, which is the edible oils, fat and waxes, which is we're in this chapter we're going through the introduction, glyceride, fatty acid, physical properties of trisaccharide, chemical properties of triglyceride, sources of edible oils and manufacture, processing and refining oils and fat stability and antioxidant, and also the method of analysis and testing of fat and oils. So this is all the contents, and I'm in charge to explain about the introduction, fatty acid, and also the glyceride. So firstly, for the fat, what is fat, oils, and waxes? So fat, oil, and three of these contains esters of long straight chain carboxylic acid, and this three is belong to saponifiable group of lipids, which is fat, oil, and waxes is a lipid. So what is lipid? Lipid is actually have the properties of insoluble in water, which is we can see between oils, and when we mix oil and water, they will not mix together because they're insoluble in water, because lipid is insoluble in water, and then they soluble in organic solvent. For example, a non-polar solvent, which is we can see here, they will have the hydrogen bonded. So the lipid will soluble in non-polar solvent, and also saponifiable group of lipids. So saponifiable, or we can say is as a saponification. So what is saponification? So next we can see saponification is actually the saponifiable lipids contain an ester group and react with hot sodium hydroxide and undergoing hydrolysis, or the other name we can say it as the saponification. So or we can say the chemical process in which an ester is heated with aqueous alkaline, which is sodium hydroxide, to form an alcohol and the sodium salt that called soap. So we can see the equation that I already wrote. This ester is going to be fat or oils or wax, will react with sodium hydroxide and it will become carboxylic acid plus alcohol. Carboxylic acid is actually the fatty acid, or we can call it the salt or soap, and also alcohol is the glycerol. So next, we can see here lipid react with hot sodium solution. Liquid can be fat, oil, or waxes, which is they will have no reaction if the lipid have no ester group, which is the example is steroid, prostaglandins, and leukotrienes. And for the lipids that will have the reaction, which is hydrolysis reaction, the lipids will contain ester group. For example, oils, fats, waxes, or phospholipids. So next, for the saponification process, which is fat and oils are ester of glycerol, in which each of the three hydroxyl be converted to an ester. We can see here ester react with sodium hydroxide, become carboxylate plus alcohol. An acid portion of ester linkage usually contain an even number of carbon atoms in an unbranched change of 12 to 24 carbons atom. We can see acid portion is a carboxylic acid, the carboxylic acid or the fatty acid. So next, the triester of glycerol fats and oils are also known as triglyceride or TAG. So the example is this one. This is the TAG, or this one. This a reaction. Triglyceride, which is an ester, we react with sodium hydroxide and become glycerol plus 3 fatty acid, which is the carboxylic acid. So the reaction will be take OH from alcohol and H from the carboxylic acid, and it will become 3H2O, 3 water. And this is the ester or the TAG, triglyceride. And next, which is the same reaction here, or the saponification, you can see acid plus the base or the sodium hydroxide alkali, and we become salt, or we can say we can make it as a soap. We can call it as a soap if you want to make a soap. So we can use this kind of reaction. Next, the chemical reaction between any fat and sodium hydroxide is a saponification. So it is same as the previous, which is the chemical reaction that produce soap. We can see ester, if we add with sodium hydroxide, it becomes the hard soap, and ester with the with the potassium hydroxide become a soft soap. Saponification is the alkaline hydrolysis of fatty acid ester. Yes. And the difference between fat and oil is the melting point, where actually fats are solid at room temperature, which is in 20 degrees Celsius, whereas oil are liquid in room temperature. And both fat and oil is the classes of compound are triglyceride. Next, the differences between the triglyceride fats and oils are from the hydrocarbon, which is from the length of hydrocarbon chains, and also the number of position of double bond that it will become saturated or unsaturated. And for the unsaturated bond, the hydrocarbon chains of the fatty acid may be completely saturated, or saturated fat, or may contain one or more double bonds one or more double bonds. And the geometric configuration of the double bond in fats and oils is a normally cis. We can see here is normally cis, and if the change includes more than one double bond, the fat is called polyunsaturated. This one is polyunsaturated. So if they change the presence of double bond puts a kink in the regular zigzag arrangement characteristic of saturated carbons. Because of this kink in the change, so we can see the example here. This is kink. The presence of double bond, because of this kink in the change, the molecule cannot form a neat, compact lattice and tend to coil. So unsaturated triglyceride often melt below room temperature and thus classify as oil. So the next one is, this is some of the example between which is the difference between fats and oils that are Google, which is we can see fats are oil substance in animals body, and oils we can see are viscous liquid that occur in fruits or seeds of a plant. So next, fats and oils are which is source of energy, which is it will bring, they have like more energy per gram compared to protein and carbohydrates, and which is fat and oil also carry of fat soluble vitamins and essential fatty acids, food flavors, cooking oils, commercial application, which is it can be soaps, detergents, emulsifier, inks, protective coating, and more. Next is waxes. So wax is actually the monoester of long chain fatty acid. Mono is one, which is one ester of long chain of fatty acid, which is the carboxylic acid. And 24 to 28 carbon atom with the long chain primary alcohol. And also a fatty alcohol has a primary alcohol group, which is the CH2OH primary alcohol that attached to a 16 to 36 carbon atoms long chain, we can see here. And also waxes are normally saturated and are solid at room temperature. Next, wax can be classified classified according to their origin, which is which they occur naturally, and also the synthetic. So for the natural, it divided into two, which is the wax from animal. Vegetable animals is actually from the beeswax, from the bees itself. You can see the picture here. Vegetable for from Carnauba, which is uh, a species of plant. We can get the wax from their seeds or their leaf, and the minerals, of course, from the petroleum. We can see mineral petroleum, which is we can find in Vaseline, which is have the petroleum jelly, one of the ointment that we use. And also the synthetic is from derived from chemical and enzymatic reaction, which is for example paraffin waxes from petroleum. Next, fatty acid. So what is fatty acid? Fatty acid is actually the carboxylic acid obtained from the hydrolysis of fat or oil are called fatty acids. Normal saturated fatty acid have a long unbranched hydrocarbon chain having a general formula of CH3, CH2, and COH. And they are the building blocks of triglyceride and the fats and oils. And also the unsaturated fatty acid may have one double bond, which we can call it as the monosaturated, or have more than one, which is the polyunsaturated. So this is the table illustrate the source and the composition of normal waxes. We can see the beeswax. The main component is the myricyl, I guess, palmitate, which you can see here, the example. This is the main component of the beeswax. Next, the following three systems of nomenclature are in use for naming fatty acid. The first one is the common trivial names, which is from the initial sources of fatty acid. We can see, for example, for the butyric acid is a major component of the butter flavor, and also the number of carbon atoms in the chain followed by the double bond, and also the IUPAC system, which we already know that where the carboxylic acid will end by the oic acid. Next is the table 4.2 illustrate, for example, we can see here, yes, saturated fatty acid, three carbon atom that have three carbons. The systematic name will call propanoic acid. The common name is propionic. Yes, which is the common source is from bacterial fermentation. Next is glyceride. Glyceride is actually the glycerol that can be esterified with one, two, or three fatty acid to produce mono, di, or triglyceride. So here glycerol, which is will react with this is alcohol. Glycerol is alcohol, react with carboxylic acid or fatty acid, and it will become ester, which is a fat with three different carboxylic acid triglyceride. Next, the properties of triglyceride (TAGs) depend on the fatty acid composition and location of fatty acid on the glycerol actually. So the natural fat and oil are designated as the TAG triglyceride in terms of saturated and unsaturated acid and isomeric form, which is, for example, we can see table 4.3. So this table 4.3 is actually illustrate the triglyceride types and isomeric form of some natural fats. GS3 we can see here in the table refer to a fully saturated glyceride, and GS2U refer to a glyceride composed of two saturated acid and one unsaturated acid, we can see here. And this we can see it will be. So here we can differentiate between the 1, 3, and 2 position permit identification of SUS, and SSU is the isomer of GS2U because they have like two saturated. So 1, 2, 1 and 2, and 1 unsaturated, 1 unsaturated, 1 unsaturated, and USU and UUS isomer is the isomer of GSU, which is consists of two unsaturated, 1 2 and 1 2, and one saturated, 1 and 1 saturated. Next is stereo specific numbering as a system, which is SN, is used to indicate the location of specific fatty acid in triglyceride. So for example here we can see 1 stearoyl, 2 oleoy, I guess 3 myristoyl, SN glycerol, which is the respective fatty acid are indicated in the 1, 2 and 3 positions. And this kind of information is very valuable in relating properties of certain fats to compositional data. So this table we can see the fatty acid composition of some edible oils and fats. That's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Afiq bin Nur Azmi and my metric number is 1170842. So I am going to present about two things, which is the first one is the physical properties of triglyceride and the other one is the chemical properties of triglyceride. So let's move on to our first topic, which is the physical properties of triglyceride. So as you can see in this slide, we have 5 main points of the physical properties that we are going to discuss. So the first one is the melting point, the second one is the specific heat, and then viscosity, density, and the refractive index. But before we are going further to discuss about these all 5 topics, we need to remember that all these physical properties depends on the types of fatty acid that present in the compound, and also the chain length of the fatty acid, and also the position and location of the cis-trans double bond of the fatty acid. So now let's take a look at the first point, which is the melting point. So melting point usually occurs over a wide range of temperature, and this melting point also depends on the triglyceride composition. Okay, so as you can see, the relationship between melting point and the chain length is the higher or maybe the longer the chain length, the higher the melting point of the fatty acid will be. Okay, and then the trans fatty acid have higher melting point than their cis fatty acid. This is because the configuration of trans fatty acid is much more stable than their cis fatty acids configuration. Okay, and then the last one is melting point are very useful in animal fat and processed food. Okay, but the melting point data are not very useful for the vegetable oil because the oil usually exists as liquid at ambient temperature. Okay, now let's move to our second point, which is the specific heat. So what is actually the specific heat? So specific heat can be defined as the ratio of heat capacity of a fat to the heat capacity of water. Or in the second point is the quantity of heat required for a 1 degree temperature change in a unit weight of fat. That means how many energy or heat is needed to increase the temperature of the fat by 1 degree. Okay, although more fatty acid their specific heat are quite comparable, but it can be said that the higher the unsaturation of fatty acid will also lead to the higher value of specific heat. Okay. So as example, liquid fats have almost twice the specific heat value than those of solid fat, which means that liquid fats are more unsaturated than solid fat. Okay, and the application of the specific heat is it is very useful in the processing operation. Okay, and then we are going to discuss about the viscosity. So viscosity can be said as a measure of its resistance to flow. So viscosity in Malay we call the kelikatan. And this viscosity is very important factor to be valued in designing the systems. Okay. As we can see, the longer the chain length, the higher the viscosity will be, and the higher the unsaturation of the fatty acid, the viscosity of the fatty acid will be decreased. Okay, as you can see from this statement. Okay, and then viscosity is also a function of molecular size and orientation of the molecule. And then there is approximately a linear relationship between the log viscosity and temperature. So, lastly, and the application of viscosity is viscosity of oils will increase in prolonged heating, which is result from the polymerization process, such as gum formation. Okay. So the next one is the density. So what is density actually? As we all know, density is mass divided by volume, right? Okay, so you can see this. Density is an index of the weight, okay, which refers to the mass, as what I said earlier, of a measured volume of the material. So this density properties is very, very important for designing of equipment and also for the estimation of solid fat index, so SFI. So this solid fat index usually is being used to determine the percentage of solid in the fat at a given temperature. Okay, and this solid fat index is being useful to margarine manufacturers or other processors who need to control the characteristic of their manufactured products by blending. Okay, and then the last one, the last physical properties that we are going to discuss is the refractive index. So basically, refractive index are very, very sensitive towards the composition of the fatty acids. Okay, the relationship between the chain length and refractive index is the longer the chain length of the fatty acid, the higher the refractive index value would be, and also the higher the unsaturated of the fatty acid, the value of the unsaturated of fatty acid, the higher also the refractive index value will be. So this refractive index value is very, very important in order to do a spot test to confirm the uniformity of the oil and fat. Okay, and then refractive index is also being used as an additive as well as constructive property, and also is being used as a control procedure during hydrogenation process. So next, we are going to discuss about the chemical properties of the glycerides. So this is the chemical properties which is involved in the triglyceride. So the first one is the hydrolysis, methanolysis, interesterification, and then hydrogenation, isomerization, polymerization, and autooxidation. Okay, so from seven, I think seven, yes, from these 7 chemical process, the process of hydrolysis, methanolysis, and interesterification is being discussed for the production of fat and edible oil, while the other 4, which is the autooxidation, polymerization, isomerization, and hydrogenation, are also being discussed, but it is also for the process of edible oils. Okay, so let's move on to our first chemical process, which is the hydrolysis. So what is hydrolysis actually? So hydrolysis is the process which involves the reaction with the water, means H2O. Okay, remember that. So the fat or oil can be hydrolyzed into fatty acid and glycerol. Okay, and then the reaction is reversible and is catalyzed by inorganic catalysts such as zinc oxide, magnesium oxide, calcium oxide, and an acid catalyst, aromatic sulfonic acid. Okay, based on this chemical reaction, so this is actually the triglyceride. Why is it triglyceride? Because we have 3 molecule of glyceride here, 1, 2, and then 3, so we call it triglyceride. And then we react it with 3 molecule of water. Okay, so why does we need to react those triglyceride with 3 mole of water? So we are going to discuss later. Okay, and then the reaction is reversible. Okay, and then it produces glycerol. Okay, this is glycerol. Okay, and then this is the 3 molecule of fatty acid. Okay, so why we are going to use 3 mole of water in order to react with triglyceride? Because H2O will H2O will react as a nucleophilic site, and the oxygen atom in the H2O will attack the C double bond O in the triglyceride. Okay, mean nucleophilic attack. And after using 3 molecule of water, and then we are going to obtain this glyceride. Okay, if we only use 1 molecule of water, then we are not going to obtain glyceride. Okay, and then after using 3 molecule of water, we also get 3 molecule of fatty acid. Okay, and then glyceride can also be hydrolyzed by treatment with alkali. Okay, which is the saponification process. Okay, just like we discussed earlier, the triglyceride react with 3 mole of water, but in this case we use 3 mole of alkali, which is potassium hydroxide. Okay, potassium hydroxide. Okay, and then after the treatment with the 3 mole of potassium hydroxide, glycerol will also form, but before this we got 3 mole of fatty acid, but in this case we are going to obtain 3 mole of alkali salt, which is in our daily life we use as a soap, sabun. Okay, now so let's move on to our next chemical reaction, which is the methanolysis. Okay, so the fats and oil react with methanol to produce fatty methyl ester. So means here is methanolysis is the reaction which utilize methanolysis as the reactant to be react with the fat or oil, okay, in order to produce fatty methyl ester. Okay, and then it also says that inorganic alkali, quaternary ammonium salt, and enzyme, which is lipase, have been used as catalyst process for soap manufacture. Okay, as we can see from this diagram. Okay, so this is triglyceride. Okay, so this is the methanol, 3 mole of methanol. Okay, the reaction is not reversible. Okay, is direct process to produce this we call as the fatty methyl ester. Okay, this is basically this we have 3 here. Okay, 3 3 fatty methyl ester and glycerol itself. Okay, and then by the treatment of as example here, they use sodium hydroxide. Okay, and then it produces 3 mole of this is basically soap. Okay, so and the byproducts here is methanol. Okay, and then we proceed to the interesterification chemical process. Okay, this is the right pronunciation. Okay, so what is interesterification here is the redistribution of fatty acids to change the physical properties without altering the chemical structure. Okay, as we can see from this diagram. Okay, this is 2 molecule of glycerides here. Okay, and then it combine to react, and after the interesterification process, the position of the fatty acid become interchanged between one and another. Okay, you see this is number 1. Okay, suddenly it become 2 after the process. Okay, so and it the process occurs until it become equilibrium. Okay, and the process is take place at temperature between 200 to 300. So it vary for the interesterification process to occur at a faster rate. We need to use some catalysts such as sodium methylate, and much more. Okay, interesterification also have 2 parts here. The first part is the random, and the second part is the directed. Okay, first the random. What is random interesterification? Okay, the random interesterification is the interchange process occurred randomly. Okay, just like in the diagram here. Okay, we use tristearine here. This is tristearine and triolene as an example. Okay, and the treatment with this here sodium methylate will act as a catalyst to faster the reaction. Okay, this is the product of the random interesterification. Okay, you see this is tristearine. Okay, this is tristearine, and this is the mixture of this S and O here. Okay, to become sauce here. Okay, this is the product of random interesterification. Okay, and then the last one is the directed interesterification. Okay, so the directed interesterification is the reaction temperature will be lowered enough until the low soluble triglyceride become crystallized. Okay, and from this statement, the fat can be separated into higher and lower melting fraction. Okay, so based on this diagram, you can see we have O, S, and O, but in directed interesterification, it being separate based on melting fraction. So this is tristearines, only tristearines and triolines here, and we using still using sodium methylate as the catalyst. Okay, and at the industry, the directed interesterification process is being more favored and significant because it allows the industry to convert oil into more fraction of original oil, okay, based on melting fractions here, okay, just like this, okay, S with S and O with O, okay, and it also used by the industry to produce and to combine more oil together, okay, and the next part will be covered by Husna Ahmad. Thank you.
Hi, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Husna binti Ahmad. So now I will continue what I have my friend Afi Azmi present before about chemical properties of glyceride. So my part is about hydrogenation. So what is actually hydrogenation? Hydrogenation is a reaction that make unsaturated fatty acid change to saturated fatty acid. How? By addition of hydrogen. Okay. So hydrogenation is an exothermic reaction and it will lead to an increase in melting point and drop in iodine value. So what is actually this iodine value is? Iodine value is we used to determine the amount of unsaturation contained in a fatty acid. So the higher the iodine value is, so the more unsaturated fatty acid that present in a fat. So that is what iodine value. So when it say here drop in iodine value, that means the less unsaturated fatty acid will have in the fatty acid because of the hydrogenation. So that will make it converted to saturated fatty acid. And then for hydrogenation, we have two. We have partial hydrogenation and also complete hydrogenation. So for partial hydrogenation, it can lead to isomerization of cis double bonds. This is a geometrical isomerization. So this is how the hydrogenation reaction. The hydrogen will attack the double bond. We will this is the fatty acid and it will react with hydrogen, and then the hydrogen will be added at the C double bond C, and then this is a complete hydrogen where both hydrogen is added here and here. So it will be saturating the hydrocarbon chain. And then this is the partial hydrogenation. For partial hydrogenation, the hydrogen atoms will be moved only one side to the other side of the double bond. So it will creating an isomer. So unsaturated fatty acid usually have a form of liquid form. So when hydrogenation occurs, it will harden the liquid fat. That's because the melting point become higher. When the melting point of the fatty acid become higher, so the fatty acid becomes solid at room temperature. So this is what is about hydrogenation and addition of hydrogen in the fatty acid and make the unsaturated fatty acid become saturated fatty acid. Okay, so the next one is isomerization. The configuration of the double bond in naturally occurring fatty acids present in oils and fats is predominantly in the cis form. So what does it mean? As I have presented before about hydrogenation, we have complete hydrogenation and also partial hydrogenation. So in partial hydrogenation, under a condition of partial hydrogenation, a double bond may change from a cis to trans configuration. So this is what we call as geometrical isomer, or it also may move to other position in the fatty acid carbon chains. So this is what we call as positional isomerization. This is can happen. Isomerization can happen in hydrogenation reaction. So isomerization can occur if oils and fats are heated at temperatures above 1000 degrees Celsius in the presence of bleaching, earth, or catalyst. Okay, next is polymerization. Under deep frying condition, 200 to 3000 degrees Celsius, the unsaturated fatty acid undergo polymerization reaction, which will form a dimeric, oligomeric, and polymeric compounds. So the rate of polymerization increases with increasing degree of unsaturation. The more unsaturated the fat is, it can be polymerized better, because saturated fatty acid are not polymerized. The cyclohexene ring is readily dehydrogenated to an aromatic ring. It's readily dehydrogenated to an aromatic ring. Hence, compounds related to benzoic acid can be formed. So on the other hand, oxidative polymerization, it will involve formation of COC bond, and polymers with ethyl peroxide linkage are formed in the presence of oxygen. So they may also contain hydroxy, oxo, or epoxy groups. So actually such compounds are undesirable in deep fried oil or fat because they will permanently diminish the flavoring characteristic of the oil. So our oil will be not taste good. It will diminish the flavoring characteristic of the oil or fat, and also will cause a foaming problem, like when we fry an egg using the oil. After that, we will have a foaming problem of the oil, so that's not good. Okay, so the last one is in chemical properties of glyceride is autooxidation. So what is autooxidation? Autooxidation is any oxidation that occurs in the presence of oxygen. So the term is usually used to describe the degradation of organic compound in the air as the source of oxygen. So this autooxidation will produce hydroperoxides and cyclic organic. That peroxides can react further to form many products. Okay. Autooxidation of a fat or oil yield a mixture of products that include low molecular weight carboxylic acid, aldehyde, and methyl ketone. This is types of products that can be produced by autooxidation. So drying oil such as linseed oil contains many double bonds. So these oils are purposely allowed to undergo air oxidation. They are purposely allowed to undergo oxidation so they can get a tough polymer film on the painted surface. So there are 3 steps involved in autooxidation reaction. First one is initiation, propagation, and termination. Okay, for the initiation step, it will lead to the formation of hydroperoxides. It will lead a formation of hydroperoxide. So this is initiation step. This is our unsaturated fatty acid, and when it undergo autooxidation, the initiation step we will have a peroxide radical. This is the hydroperoxide that we said. This is it will react with oxygen and then become hydroperoxide in radical form. And then next, the second step is a propagation step. It adding another molecule to the hydroperoxide radical to generate new free radicals. So this hydroperoxide we will be added a new molecule and it will lead to a new free radical molecule. Okay, so the last one is a termination step. So what happens in termination step? Because of the chain length of these two radical reaction steps, which is in initiation and the propagation cycle step, is about 100. So when the radical concentration has reached a certain limit, the chain reaction will be gradually stopped by mutual combination of radicals. So this is what we call as termination step. The reaction will stop, and from this auto-oxidation reaction, numerous compounds will be resulted from the reaction. So this is the termination process step, and it will stop. This is the last product, and any product will be numerous product will be produced from this reaction. Okay, so next we will continue to the source of fats and oils. The sources of edible oil and main fats. So as we can see here, this is a pie chart of consists of edible oil or fat production globally in 2015. So 31% are from palm oil, 22% from soya, 13% from rapeseed, 8% from sunflower, and 26% from other than this. So this is 4 major oils or fats globally. And here we have tallow and lard for fat production. You can get fat from tallow and lard. Other than this, we can get oil from plants: soybean, corn, canola, coconut, cottonseed, palm, sunflower, and peanut. So edible oils are mostly plant origin. For olive oil and palm oil, they are extracted from their fruits, and all other oils are extracted from their oil seeds. This is some of the seeds, as you can see here. And raw materials for fat production we get from animals organ fat. They will extract the fat. This is a pie chart about oil production, world oilseed production, but in 2003, the main oil production in 2003 is soybean. 56% is from soybeans. Okay, this is the distribution of type of plant that grow by each state. The main crop. Sorry. So for United States, the main crop is they grow soybeans. 56% soybean is from United States. For Malaysia, we grow mainly palm. Philippines grow coconut. For China, Europe, India, and Canada, they grow rapeseed for canola oil production. And sunflower is grown in the United States, Australia, Europe, and Argentina. And the cottonseed market is dominated by the United States, China, Pakistan, India, and the former Soviet Union. So that's all from me, and I will pass to the next presenter, which is Izzah. Thank you.